Hello everyone. So we will proceed further and in the previous video I have discussed about the protection equipments used in the transformer. Now in this particular video I am going to discuss about the differential protection scheme and where basically we use differential protection schemes and all. Okay, in the previous video actually I also mentioned about the differential protection schemes and all. In differential protection scheme, let's say you have an equipment with you that can be anything, like that can be any windings, that can be a part of the lines. Okay, so this is the one equipment you can say that you want to protect. Okay, so how differential relay or differential schemes basically operates. See, here current is coming and here there is a outgoing current. There is incoming current and outgoing current. So we will utilize this incoming current and outgoing current to protect the fault that occurred in this particular equipment. Okay. So let's say I have CT here on both the sides. Okay. And this is my operating coils. Okay. So this is my, let's say this is my n number of turns it has, and and what will happen, and for example I am considering it is a simple differential relay, and the cities that I have with me, these cities are identical, like both the turns ratios and all, each and everything are the same, both the cities are exactly matched. So if there is no fault in the equipments, so if I current is flowing, so I current, I is the incoming current, the outgoing current will also be I. So because of this I current, let's say I am getting, you can say kind of I prime current, and since the cities are exactly matched and the outgoing current is also same, I will be getting same I prime current here also. So here also the I current is I prime. So the current that is flowing through the operating coil, it is my operating coil, real operating coil. So our current flowing through the operating coil will be simply zero, and there will be no operation. There will no trip signal sent to the circuit breaker. But now let's say you got a fault, you got a fault in the equipment. So the current that will flow, that the incoming current will be I1, and the outgoing current will be I2, because some of the current will come, the current will flow through this fault point also. So because of I1 current, let's say you are getting some current I1 here and some current I2 here. So here your current is I2, I2, and the current that is flowing here I1 minus I2. Now this is non-zero current, and anyhow if this particular current is more than the specified value, so this particular coil will produce a force, and and it will send the trip signal to circuit breaker and it will trip. Okay, so this particular equipment can be alternator, armature winding, transformer winding, any part of the transmission line. But in transmission line protections and all, we generally don't use this differential protection scheme, because we have to place the cities the far away, like the location of the cities will be at the like the distance between these two cities will be very far. Okay, so it is practically not possible, but there is a way to do that. So but mainly we use in transformer and alternator or synchronous motor and winding protections, or even we can use in winding protection of the maybe in induction motor. Okay, but there is a issue with this simple differential relay, because in practically you may not get the exactly matched CTs, like the turns ratio may differ. So even if the I current is flowing in the incoming current is I and outgoing current is I, so you may get current here I1, and you may also get the current I2, because this, even though these currents are same, but because of the CT ratio error and all, CT that trans ratio error and all, you will end up with some different secondary currents, and that secondary current can also excite this particular operating coil, and it can lead to maloperations. So if there is no fault, then also this particular relay coil will send the trip signal to circuit breaker and it will trip it. Okay, so how to avoid it? So we use, basically there is one coil, something we call restraining coil. Okay, that restraining coil we have to use here, restraining coil. Okay, so let's say you have restraining coil the turns, number of turns are nr, so I'll be using nr by 2 turns here and nr by 2 turns here. Okay. And let's say this is your circuit diagrams, and let's say there is no fault and all, and incoming current is I and outgoing current is also I. So here your current will be I1, and here your current will be I2, and here the current will be I1 minus I2. See, these currents will not be same because you will not get two cities that are exactly matched. So if you see the MMF that gets created because of the restraining coil, FR nr by 2 into I1 plus nr by 2 into I2. So nr by 2 I1 plus I2, this is your MMF gets created because of restraining coil, and MMF created because of operating coil will be I1 minus I2 into N. Okay, so what we do, if this MMF created by the operating coil is more than the MMF created by the restraining coil, like FO is more than the FR, then this particular relay will operate and it will send the signal to circuit breaker to trip it. So this is something we call partial percentage differential relay or bias differential relay. So this is how basically we can avoid the mal-operation of the simple differential relay. Yeah. So this is the thing that I want to discuss. But still, if you have any doubt, you can ask me in the chat. Thank you.